Today we will be doing lesson 8.5, so go ahead and fix that in your notebook. It should say 8.5, graphing logarithmic functions. So let's write out the logarithmic parent function. That will be f of x equals, let's try this again, f of x equals log x. So a logarithmic function is the inverse of an exponential function. So our log function, which if you remember is log base b of a equals x, that is the inverse of the exponential function. So you might have remembered we did this earlier in this chapter or unit where we graphed exponential functions. Why is my pen? Okay, there we go. We did this earlier in the unit where we graphed exponential functions and we got those, the points where we had x is -1, 0, 1, and y was 1 over b, 1, and b. And we did this pattern, and that, again, that was for exponential functions. Well, today we will be doing the same idea, but for log functions. And you will see that it will be the inverse of these values right here. Okay, so let's go ahead. It says a log, using your graphing calculator, sketch the following graphs. So if you were to put these into your calculator, you would get something that looks similar to this. Your log x graph. And then you would have, if you did your 10 to the power of x graph, it would look something like this. Now it says, because you can only graph base 10 logs on your calculator, you will need to use the inverse exponential function. Then invert the values from the table to graph the logarithmic function. So I already gave you those values for exponential function. So since the log graph is the inverse, we will be inverting those values, which you will see in a minute. So parent function for logarithms. We have y equals log base b of x, or it can be written as natural log. Well, y equals natural log x. So for this one right here, we are going to do the parent function, but we are going to do it for natural log of x. And our vertical asymptote for a natural log of x, whereas if you remember exponential, we had a horizontal asymptote that looked something like this, where it was a horizontal line along the x-axis. Well, for the natural log or for log parent functions, let's see why I want it right. Here we go. Okay, our asymptote is a vertical asymptote. Let's see why. Here we go. It is a vertical asymptote. Because again, it's the inverse. Now let's go ahead and get our x and y values now. So we have x. Now let's get our x and y values. So we have x and y. Now again, we're going to do the inverse of our exponential function here. So instead of our x's being -1, 0, 1, we will make our y's -1, 0, 1. So let's write that down, -1, 0, 1. And our x's will now be 1 over b, 1, and b. Oh, that one never got written. Okay, so let's go ahead and graph this one right here. We have the natural log of x, so that's going to look more like this, 1 over e, which if you remember, e is 2.718. And then we have our 1, and then we have our b right here is just e. Okay, so we're going to do 1 over 2.718, then down 1. So that's like 1/3 of the way, and down 1. So we're going to put our point about right here. The next one is 1, 0. 1, 0. So that's about right there. And then the other one is 2.718. So that's almost 3 and go up 1. So 1, 2, 3. I'm going to go up 1 right before it. Connect those points. And we have our graph right here. I'm going to go ahead and extend that graph a little bit further. There we go. Okay, if you notice here, our vertical asymptote will always be x equals 0. And our x-intercept will always be 1, 0. Okay, let's go on to this problem right here. Y equals log base 2 of x. So again, let's get our x and y chart here. Let's write our x and y chart. Again, remember, we will now do, instead of the x's, we have our y's because it's a log graph. So -1, 0, 1. And we have 1 over our base. Our base here is 2, so 1 over 2, 1, and then just our base, which is 2. So let's go ahead and graph those points. Well, first let's graph the asymptote, our vertical asymptote here. Now we have 1/2, -1, so go 1/2 of the way down 1, then 1, 0, and then 2, 1. We have our 3 points. Connect those. Don't forget your arrows at the end. Okay, let's go to the next one. Y equals log base 5 of x. Let's get our x and y chart here. So we have our x and y chart, x, y. Our y's are -1, 0, 1. Now -1, we have our x is 1 over b, which is 1 over 5, and 1, and our base is 5. So now let's go ahead and go write our vertical asymptote here. There we go, vertical asymptote. Go 1/5 of the way down 1, 1/5 of the way down 1. Then we have 1, 0, which is right here, and then 5, 1, right here. So we have our 3 points, connect those 3, and we have our log graph. Now, natural log of x. Next, well, we just did that up here, so you can copy that down. Okay, now number 1, it says sketch the graph of the following. So we have some transformations going on here. We have this +1. Well, if you remember, that +1 right there means left 1. And let's go in and do everything else the same. Oh, by the way, left 1 means our vertical asymptote will be going to the left 1. So we can put that on here right now. I'm going to make my pen a little bit thinner here so it will work better. Okay, so let's go and do our vertical asymptote to the left 1. There we go. Our origin stays the same. Let's get our x and y chart. Our y's are -1, 0, 1. Our x's are 1 over the base, which is 1 over 3, 1, and 3. No changes need to be made to the x and y's. Now let's go ahead and put these points on our graph. We're going to go over 1/3 of the way down 1, 1, 0, and 3, 1. So 1, 2, 3, up 1. Right here, connect those points. Okay, number 2. Let's go ahead and look at number 2. We have this x minus 2, which means we will be going to the right 2, which our vertical asymptote goes to the right 2. And then we have this +3, which means our origin goes up 3. So let's go ahead and write our origin up 3 on here. So 1, 2, 3. So it's going to be right there. That's our new origin. Okay, let's get our x and y's on here. And remember, we have our y's are -1, 0, 1. And then we have 1 over e. Well, we have this natural log, which is the same as log e. So it's 1 over the base, which is 1 over the base, which is 1 over e, 1, and e. And by now you should know e is 2.718. So let's go ahead and go start at our new origin, which is right there. So let's go ahead and do 1 over e, which is basically 1 over 3, 1 over 2.718 down 1. So about 1/3 of the way down 1. There we go. And then we have 1, 0. So we're going to go 1, 0. And then we have about 2.718 and up 1. So 1, 2, 3, and we're going to go up 1, about right there. And then go ahead and connect those points. Let's go to number 3. We have this -2. This -2 tells us our origin will go down 2. So let's go ahead and put in our vertical asymptote here. Here is our vertical asymptote. And let's take our origin down 2. So 1, 2, there's our new origin. Let's get our x and y values here. So we know y is -1, 0, 1. Then we have 1 over the base. Our base here is 10. So we have 1 over 10, 1 and 10. So let's go 1/10 of the way down 1, about right here. Then we have 1, 0, and 10, 1. So let's go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up, 10, and up 1. Let's go ahead and take that up 1. Good. So now we have our 3 points. Let's go ahead and connect those. Do your best to connect them. They're kind of far apart. All right. And we have those. All right, let's go to number 4. We have this -x. So if you remember, that means we will reflect y, which means we will change x, change our x values. Okay, so let's first go ahead and write down our x, y, just how our pattern, -1, 0, 1. And then we have 1 over b, which is, in this case, again, ln means log e. So we're going to do 1 over e, 1 e. Okay, now let's change x. So I'm going to go in with the red pen and change my x's. There we go. Now we are ready. So we know our vertical asymptote is right here down the middle, down our y-axis. And let's go ahead and put our points on here. -1 over e, -1. So that's about right here. And then we have -1, 0. And 2.7, or -2.718, so 1, 2, 3, and up 1, so about right there. Connect those 3 points, and we have our graph. Okay, let's look at number 5. We have this negative in the front. What does this negative tell us to do? We will reflect over x, so reflect x, which means we will change y values. So let's change those y values. So let's go ahead and get our x and y values on here. X, y, -1, 0, 1. And then that's 1 over the base, 1 over 5, 1, and then the base, which is 5. Now we will go in with the red pen and change those y values. Now we have plus and a minus. So we have 1/5. Oh, we forgot. Let's do that vertical asymptote. Now we go to 1/5 of the way plus 1. There we go, there's our point. Then we do 1, 0, and 5, -1. Connect those 3 points, and we have our log graph. Number 6, we have natural log here. This x plus 1. This plus 1 means our vertical asymptote will go to the left 1. So let's go and do left 1. And then our origin here will go down 2. So let's go ahead and move that origin down 2. There is our new origin. Now let's get our x and y values. Right, y's are -1, 0, 1 because it's a log graph. And then we have our x's is our 1 over b, which in this case will be 1 over e, 1, and then our base, which is e. Now we will go start at the origin. We will go over 1 point, like 1/3 of the way, then down 1. So 1/3 of the way down 1, then 1, 0, then 3, almost 3, 1, 2, 3, 2.718. Now we connect those 3 points. Okay, number 7. We have some things going on here. We have this -x, which means we will reflect over y, so reflect y. So it will reflect y, which means you will change x. Change x. Then we have this up 1, which means our origin will go up 1. So let's put in our asymptote. Our origin goes up 1. And let's go ahead and get our x and y values on here. Negative 1, 0, 1, 1 over e, 1, let's make that 1 over e, and then e. Now, that change x, let's go in with the red pen, change x. You can use whatever color, or you could just use your pencil, either way. All right, let's go ahead and graph this. So we go negative 1/3. We go negative 1/3 of the way down 1, which is 1 over e, negative 1, 0. Okay, so we have our negative 1, 0, and then negative 2.78 up 1, so 1, 2. So about right here. There we go. And connect our points, our 3 points as best as you can. Okay, number 8, almost done. That negative in front tells us we will reflect x, which means we change y. Then we have this 1 right here, which means we will go to the left one with our vertical asymptote. So let's go to the left one right now. Now we can put our x and y values. Negative 1, 0, 1. Then we have 1 over base, which is 1 over 5. And then we have our 1, and then our base, which is 5. Now let's go in. I'm going to go in with the red pen and change y. So we have, that changes to a plus y, and that changes to a minus y. Okay, let's go ahead and put those points on our graph. So 1/5 of the way, plus 1, 1, 0. And then we go 5, negative 1. And there is our graph. Number 9. We have negatives on that ln and negative x. So that tells us we will reflect x and y. So that tells me I need to change both x and y if we're reflecting on both. So we have our x and y values. Let's just write out our values, our pattern. Now we have 1 over e. Then I have 1, and then I have my base of e. Now I'm going to go in with my red pen, change all my x's, and I'm going to go in and change my y's. Now I can also put in my vertical asymptote. My origin's at 0, 0 still. Okay, let's go ahead and put these points on here. I have negative 1/3 of the way plus 1. I have negative 1, 0. And then I have negative 2.78, 1, 2, down 1. Connect those 3 points. And I am done. All right, you are ready for the homework.